Okay, hi guys, here we are going to solve this last numerical for BME, okay, BME GTU exam 2022 summer. Okay, this last one. Okay, it says that determine the efficiency air standard of Carnot cycle for the following datas. Minimum temperature of the cycle is 27. Okay, so the first thing, it is question number 5C. The first thing we have to do here is to determine this efficiency of this Carnot cycle. We have to have two things that are very important. Okay, now let me draw first, okay, before start computerizing or trying to find the values and things like that. Let me just write first. Draw this one, this line, and this line, and also this line. Okay, this is not a straight line, this is a curved line. Okay, and this as well as this one, it's not a straight line, this is also a curved line. Okay, now it's okay. So here we have point 1, point 2, point 3, and point 4. So this is Carnot cycle. This is PV diagram of Carnot cycle. So for Carnot cycle, it starts with a isothermal expansion. Okay, isothermal expansion. Why? Because volume is increasing. Isothermal expansion. Then we have here isentropic expansion again. Okay, we have two expansion followed. Okay, here this is isentropic expansion, 2 to 3 isentropic expansion, 1 to 2 isothermal expansion. Then from 3 to 4 we have isothermal compression, and from 4 to 1 we have isentropic compression. So compression, expansion. Okay, now they say what? They say that the minimum temperature of the cycle is 27. The minimum temperature of the cycle, minimum temperature of the cycle. The minimum temperature of the cycle is lying between this one. Okay, when the pressure is lower, temperature lower also, this one. So the minimum is here in between 3 and this one. So TL, I will call this temperature here TL, and here T high. This is the highest temperature in the cycle. This is the lower temperature in the cycle. Okay, so the minimum is T lower, that is the same as T3 equal to T4. Nice. Now they say what? They say the minimum pressure in the cycle. Okay, minimum pressure in the cycle, this is the beginning, this one. So you can just see by this cycle, you can see the minimum pressure is this one. Okay, the minimum, it is P3, and it is 1 bar. So this is 27 degrees Celsius. Convert this to SI unit. This will be 300 Kelvin. This one will be 1 times 10 to the power 5 Pascal. Okay, now what's the next data that they give us? Pressure after isentropic compression. Pressure after isentropic compression. So what is isentropic compression? It's here. So what is the pressure after this isentropic? It is this one. So P1, okay, P1 will be 4.5 bar. This will be 4.5 times 10 to the power 5 Pascal. Then what do we have? Pressure after isentropic compression. Oh, sorry. They say pressure after isentropic compression, it is 12. Okay, this is 12, sorry. 12. Say 12. Okay. It is 12. Now we are fine, okay? Just this is 12. Pressure after isentropic compression. Isentropic compression is this. Okay, pressure after this one is 1, P1, it is 12. Now I forgot telling you that there is also a data here. They said that pressure after isothermal compression is 4.5. We have to be attentive. Isothermal compression, it is after, it is over here, P4. P4, it is 4.5. Okay, this is 4.5 bar. And this is what? 4.5 bar? This is 4.5 times 10 to the power 5 Pascal. And they are asking for this one. What is this? As we know, standard Carnot cycle efficiency, it is given as 1 minus T lower, the lowest temperature, upon the highest temperature. So here, what is missing to calculate this one? Time 100, okay, time 100%. What is missing to find out this efficiency? TH, okay, and TH, it is the temperature T in T1 or in T2. So here we can find either here or either here. Okay, how to find TH? That's the point. We do not have P1, V1 here, D2. So to find TH, okay, TH, that is the same as T1 or T2, we can either calculate this, we can either work with this pressure and this pressure, okay, these two pressure. But the point is that we do not have P2, but here we have P1 and we have P4. So we will just grab P1 and P4. These are the most important thing for us, P1 and P4, okay. From P1 and P4, okay, P1 and P4, we know T4. T4 is equal to T3, and this is equal to TL. This is 30 Kelvin. Now, as we know, here it is adiabatic, or I cannot say, it is a reversible adiabatic process, isentropic process. What does it mean? It means that here we have pressure, and we have temperature. So we can use the PVT relation, between this, okay, isentropic process, but working only with pressure and temperature. So we know T upon P gamma, okay, this is isentropic, it's gamma minus 1 upon gamma, okay, gamma minus 1 upon gamma is equal to constant. So here T1 upon P, in this case P1 upon P1 gamma minus 1 gamma is equal to T2, not T2, sorry, T4. We are solving from there, okay, T4 upon P4 gamma minus 1 upon gamma, okay. If this is true, so from here we can find what is TH, okay, because TH is T1 is T2, so TH, this one, just go there. So TH, that is T1, is equal to T4 times P1 upon P4, all to the power gamma minus 1 upon gamma. Okay, now here just substitute and find what is TH, okay, the highest temperature. Now, as you can see here, okay, TH, as you can see here, okay, TH will be ended in 397.03 Kelvin. Okay, just substitute all the values here, you'll find TH. Now, after finding TH, just substitute here, okay, substitute there in the formula. Okay, what we will get? So directly we will get this one, TH. Okay, now that we have TH, it will be 1 minus TL, we know the lowest temperature, okay, TL, lowest temperature, it is 30 300 upon TH. TH is 397.03. Okay, time 100. Okay, now this one, so you get 1 minus 300 divided by 397.03. Okay, so the efficiency of this Carnot cycle will be 24.43889%. So this is what we need, and in this way we have solved this problem. Okay, thank you, and yeah, you can see it all. Okay, what we did, okay, TH, we didn't have pH, but we had the lowest temperature in the cycle. This is this one, TL. Okay, TL is T3 and T4, because here temperature is the same. Now what we have, okay, now after finding this data, we realized that we do not have TH. So what do we have to do to find TH? We just play with these two pressure, as this is reversible adiabatic process. So for adiabatic process, when we have pressure and temperature, we want to find pressure and we want to find temperature. Regarding pressure, we have this law here, over here. This is the relation between temperature and pressure, okay, for adiabatic process. Now we did this one because this is asentropic. It's like this, T1 upon P1 and T4 upon P4, and life is still good. Just for here, just you have to find what is T1. T1 is TL, it's the same, constant temperature. So just find this one. After finding this one, substitute TH there, and you're done. Thank you very much. Hope all is good with you and your family.